5 years to 65 years.
Namaste, good morning and good afternoon. Welcome to Mana TV Live Telangana channel. We are discussing about the concepts of geometry, correct? So, you know that geometry is a vast scope and a good application. Logical thinking and reasoning will play a vital role in the geometry part. Who are able to do all the questions from the geometry, definitely they will in the selection list. So, through these classes, maybe I hope you will be perfect in the geometry and you will qualify for the examination. Okay, so last class I discussed about the geometry of a similar triangle area concept, clear? Sometimes, so we can extend this similar triangle concept to other properties of a triangle. A triangle has 3 sides, 3 angles, 3 vertices, you know all of these. So, we will discuss on all the properties of this triangle. Okay, now I am going to take a simple figure called as star. Now, shall we draw the star? Okay, see. It is a star, you know that, it is a star, correct? I am naming this one as A, B, C, D and E. The question is, find the value of angle A plus angle B plus angle C plus angle D plus angle E. Find the value of angle A plus angle B plus angle C plus angle D plus angle E. This is on. Okay, then how to do it? So, very important thing in the geometry part. So, you have to identify which concept it is. It is a very important. Okay. So, already I said I am going to discuss about the triangle concept, am I correct? So, once I am discussing the triangle concept, definitely it depends on the properties of a triangle. You know that triangle have so many properties. One of them is we call it as angle sum property, correct? What is the angle sum property? Sum of 3 angles of a triangle equal to 180 degrees. So, we gave the same information in the 8th class textbook and we proved into different by using different activities and the examples. Okay. Another one is when one side of a triangle is produced, the sum of the interior opposite angles is equal to exterior angle. These are the second property. And third one, you can say vertical angle bisector theorem, other theorems also. But among all possible properties of the triangle, I am taking the first 2. So, we can recall those things. Those 2 are sum of 3 angles of a triangle equal to 180, and if one side is produced, the exterior angle formed equal to sum of interior opposite angles. Okay. Now, I am going to use these 2 to get the answer of A plus B plus C plus D plus C. Okay. Shall we see now? Okay. Now, see. So, instead of naming this angle, generally the naming of an angle with the 3 letters. For our convenience, I am saying this is angle 1, this one angle 2, this is angle 3, this is angle 4 and this one is angle 5. Here we can find so many triangles, and the importance of this problem is we can prove this statement, or we can find the value of these 5 angles sum by nearly 10 methods. You can take any one of the method as your wish, but I am taking the very simple method by using the properties of triangle. Okay. Again you observe 1, 2, 3, 4, 5 triangles. You can take any triangle as your wish. For our convenience, I am taking this triangle. So, again saying I am taking this triangle, no. So, for that reason, I am naming this point of intersections as this one is F, G, H, I and J. So, we have triangles, we can see the triangles 1, 2, 3, 4, 5, I am taking the triangle HCI. This is one triangle. So I want to name the remaining angles of this triangle. This is already used 5. So I am using this is angle number 6 and this one angle number 7. So we know that in triangle HCI the sum of 3 angles equal to 180. This is angle sum property. Am I correct? You can write the same. Angle 3 plus angle 6 plus angle 7 equal to 180 degrees. Okay. Now I am going to use the second property. When you take a triangle, if one side is produced, the exterior angle formed equal to sum of interior opposite angles. If you say this is 1, this is 2 and this is 3, then angle 3 is equal to angle 1 plus angle 2. So now I am going to use the same property here. When you consider this triangle I, E and B. Okay, when you consider triangle I, E and B, what do you notice? When EI produced, the exterior angle formed equal to angle 6, correct? So angle 6, the exterior angle is equal to sum of interior opposite angles. What are the interior opposite angles for angle 6? Angle 5 and angle 2. So what do you notice the relation between these three? Angle 6 is equal to angle 5 plus angle 2. So you can write angle 6 equal to angle 5 plus angle 2. Now I want to find, or I want to consider one more triangle. Which triangle you are going to consider? Can you say? Correct. You have to consider the angle triangle HAD. H, A and D. Why I consider this triangle only? So I want to express the relation with respect to angle 7. Now here see, when you consider H, A, D or A, D, H as your wish, so this is an exterior angle. So angle 7 is an exterior angle, correct? Angle 7 is an exterior angle. And what are its interior opposite angles? Angle 4 and angle 1. So angle 4 and angle 1 are interior opposite angles. So the relation between angle 7, angle 4, angle 1 is angle 7 equal to angle 4 plus angle 1. Okay. So now you consider the equation angle 3 plus angle 6 angle 7 equal to 180. Angle 3 itself angle 3. Angle 6 is equal to angle 5 plus angle 2. We can substitute this value in place of 6. I am taking the same equation, angle 3, angle 6 equal to angle 5 plus angle 2. So I will write the same, angle 5 plus angle 2, correct. Angle 7 is equal to angle 4 plus angle 1. I will write the same, angle 4 plus angle 1 is equal to 180. Are you understand? I take angle 3 as it is because it is a reflexive property, angle 3 equal to itself. Angle 6 is, we define an equation, angle 6 is equal to angle 5 plus angle 2, correct. Okay, angle 7 we have find one more relation, that is angle 7 equal to angle 4 plus angle 1. I substitute those two values in this, then you have angle 3 plus angle 5 plus angle 2 plus angle 4 plus angle 1 equal to 180. Now I will write it in order, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 equal to 180. Is it clear? Then what is angle 1? Is A. What is angle 2? It's B. What is angle 3? It's C. And what is angle 4? It's D. And what is angle 5? It's E. So angle A plus angle B plus angle C plus angle D plus angle E equal to 180 degrees. So hence the answer is simply 180 degrees. The importance of this, so you can draw a very big star. The sum of the 5 angles equal to 180 always, irrespective of the length of these line segments. Clear? So it's a frequently asked question in the examination. So it's a very important. Like you can give the some more. Just see, as two properties are based on this, we can find the value of angle A plus angle B plus angle C plus angle D plus angle E. Clear? Okay, good. Shall we start one more? Before that, I will give some very important theorems which is useful for the examination. We will discuss it in the statements, then we will follow the rest of the things. Okay. So, in total 10th class, up to 10th class, there are few theorems we given. When you see the previous textbook, we gave nearly 100 theorems in the total textbook, but here in the present curriculum we gave very little, of course very simple, very useful for the geometry area. The first one we call it as a basic proportionality theorem, of course we call it as a Thales theorem also. So, first one is a basic proportionality theorem. This one is a familiar as a Thales theorem. Okay. The statement of this basic proportionality theorem is, in a triangle, the line drawn parallel to one side, if DE is a line parallel to drawn one side BC, it divides the remaining two sides in the same ratio, means when DE is parallel to BC, then AD by DB is equal to AE by EC. AD by DB equal to AE by EC. This is a very important theorem on the basic proportionality theorem. We can write the relations so many times, like we can say AD by AB is equal to AE by AC also. So, by component on dividend law, by using component dividend law, we can prove it. By using this, so many questions they will ask in the examination. So, this is one of the important theorem which is called basic proportionality theorem or Thales theorem. Now, we are going to other one. So, once again before going to rub it, I will say this. What is the basic proportionality theorem? The line drawn parallel to one side divides the remaining two sides in proportion, means same ratio. AD by DB is equal to AE by EC. This is called a basic proportionality theorem. Okay, now coming to the next one is you know that Pythagoras theorem. Pythagoras theorem. Okay, so Pythagoras theorem, you know it, it's a everyone, when you say about mathematics, they will ask about Pythagoras theorem, correct? Simply, what is a, otherwise if they doesn't know, simply they will say a square plus b square equal to c square. So many constructions based on this Pythagoras theorem and very useful. Nearly 20% of number theory also based on this Pythagoras theorem, of course as a Pythagorean triplets. So, you know that, so generally the questions also may come from this area Pythagoras theorem. Okay, what is a Pythagoras theorem? In a right angle triangle, the square of the hypotenuse, here AC is the square, so square of the hypotenuse is equal to the sum of squares of remaining two sides. Sum of squares AB square plus BC square. So, AC square equal to AB square plus BC square, this one you will call it as a Pythagoras theorem. So, in the Pythagoras theorem, when you apply this is a very good application in the trigonometry, in the geometry, of course it is a geometry area, and the rest of the parts of the branches of mathematics also. The numbers based on this property of course forms a Pythagorean triplet. I will take a numbers, for example 3, 4, 5. 3, 4, 5. See that 5 square how much? 25. 4 square how much? 16. 3 square how much? 9. So, 5 square equal to 4 square plus 3 square. 16 plus 9 equal to 25. So, means 3, 4, 5 we call it as a Pythagorean triplet. Like we can say so many Pythagorean triplets, 5, 12, 13, 6, 8, 10, 7, 24, 25, like you can say so many Pythagoras triplets in this. Okay. And from this they may ask the very important question on Pythagoras theorem is based on the reasoning. So I will ask, of course, so try it. Then when I ask it as ABCD, of course, question as in a Pythagorean triplet, at least one number is even. In a Pythagorean triplet, at least one number is an even number. This question may comes in the examination is a Pythagorean triplet. Okay, how many numbers are? Of course, the following statement is true. The first one, at least one number is an even number. Okay, no one is an even number. All are prime numbers. All are odd numbers. Like when it is given in the multiple choice question, they will ask it. In a Pythagorean triplet, at least one number is an even number. This here the concept is very, very important. So if you take a number, it has a parity. That is, it may be an even number or it may be an odd number. Correct? It may be an even number or an odd number. So when you take it as these possibilities, the parities of the number, then I am taking to prove this statement here. For example, that is I will take as a ABC, which is a Pythagorean triplet. We are supposed to say ABC is a Pythagorean triplet. Means A square plus B square equal to C square. Now I am writing the possibilities. A is an even number. B is an even number. Now coming to the C, A square, even number. B square, even number. Even plus even is an even number. If you have any doubt, check it one Pythagorean triplet 6, 8, 10. 6, 8, 10. 6, 8, 10 all are even numbers. Am I correct? 6 square 36, 8 square 64, 10 square 100. 36, 64, 100. 36 plus 64 equal to 100, correct? So all are even numbers. So if when A is an even, B is an even, C also even number. So all are even here. Now I am checking the next of the parity of that. One is an even, other is odd. Okay. Even square, even number. Odd square, odd number. Even plus odd, odd number. Okay, see it. It's an even number, it's an odd number. Even square is an even number. Odd square is an odd number. Even plus odd, odd number. So it's an odd. Here we have an even. If you have an, let's take an example. 5, 12, 13. Okay. So if you take it as 12, 5, but one is an even number, other one is an odd number. So we will get an odd number. So 5, 12, 13. Okay, next possibility. Odd, even. Okay. What is the result will come? Odd square, odd number. Even square, even number. Odd plus even, odd number. Like 3, 4, 5. 3 is an odd number. 4 is an even number. Then 3 square plus 4 square, which is equal to 5 square. 5 is an odd number. Okay, now coming to the last one. Odd, odd, then you will get even number. Okay, odd square, if you consider odd square, odd number. Odd square, again odd number. Odd plus odd is an even number. Here an even number. Okay, so here you have even number. Here even number. Here all are even numbers. So these are the total possibilities. Total possibility. These are the total possibilities. Among these 4 possibilities, without even number, there is no Pythagorean triplet. Hence, we can say in a Pythagorean triplet, at least one number is an even number. It's a very important, because already you know that you are going to write this test for the PGTs or TGTs, whatever it may be. So here your mathematics means here you should know the academic standards. So problem solving, reasoning and proof, communication, connections, and representation visualization. This question comes under the reasoning and proof. So very clear. So who are able to do this reasoning and proof questions, those people only will select in the examination, definite. Because the complexity of among all 5 academic standards, these are most important. Means here good logical reasoning is very important. So if you are able to do this kind of questions, definitely you will get maximum score in the examination, and this is very important also. And one more information, this question was given, the same kind of question was given in the textbook in the concept of think and discuss. You know that the think and discuss is a little bit of beyond the standard of the classroom or the syllabi. Clear? So like when you are able to for that, we are giving excellent questions in the optional exercises also in the textbook. Prepare optional questions for the examination. Don't expect the same question comes in the examination, because it's not a academic examination, it's a competitive examination. So but the questions will come based on these exercises. So because the concept, because you are testing the concept, so if you are following those questions also, it's a very good thing. Clear? Okay. Now I am going to take one more. This is a reasoning and proof. Now I am going to take one more question on the Pythagoras theorem. That will comes under the problem solving. ABC is a triangle, and just a perpendicular line drawn. Say it's BD is a perpendicular line, its length is B. Okay, and then you are going to prove that. Say this is B, and this one is A, and this one is B, C. Okay. So you have to find the value of 1 by P square. What is its value? You are going to find what is 1 by P square value. The length of BC is A units, length of AB is C units, and the length of AC is B units. In general, we will follow the notation that we will represent the opposite side of an vertex with the same letter. So here BC, it is opposite to the vertex A, so it is represented by small a. Its length is represented in the manner. And here AC, it is opposite to the vertex B, so we will say as B. And it is opposite to vertex C, so the length of AB is represented in C. We are going to find the value of 1 by P square, where BD is perpendicular to A. And we said BD is equal to P. How to do it? How to do this? Any idea from your side? We can prove by a Pythagoras theorem by using similar triangle concept also, or Pythagoras theorem also. So don't feel that every problem will do in the particular method only, that's wrong. So this is examination, so speed and accuracy is the most important. When you observe this figure, so when you have a perpendicular line, immediately in the minds of you should come as altitude. So what is the use of altitude here? The area. So if you consider the area, you will get answer directly. Okay. Now I am taking the triangle ABC in this projection from top to bottom. So A is the base and C is the length of the height, of course altitude. So means you know the base, that is A, you know the height C, then what is the area of triangle ABC of base, that is A, into height of ABC equal to of AC, simply we can say it. Clear? Okay. Now coming to the next one. So when you come into the next one, I am using the same area concept for this another angle of projection. I will see from B. Then AC will be the base and BD will be the height. So we can say area of triangle equal to of, what is the base here? AC, which is equal to B, and what is the height here? It's BD, its length is P. Both are represent the same. means of AC equal to of BP or PB. So simply we can say of PB is equal to of AC. You can cancel off on both sides. So PB is equal to AC, correct? Okay. So or we can say P is equal to AC by B, or P square is equal to how much here? A square C square by B square. What is required? 1 by P square is required. So 1 by P square equal to B square by A square C square. That's it. Clear? Like you can find the values of the required ones. So here, so once you are going to, you know, there is only 2 theorems, so I want to apply for each and every question and the same means it's not the meaning. So that's a very, very important. So here, for especially for mathematics, if you want to get success, you have to identify which area is mostly required. That's the most important. Clear? Okay. Now coming to the next area, we will see that we discussed 2 theorems. One is a basic proportionality theorem, and second one is a Pythagoras theorem. So we have one more. We call it as a vertical angle bisector theorem. That's the most important. When you consider a triangle ABC, yeah, A is a vertex angle, draw the angle bisector, correct? When you consider the angle bisector, so say AD is the angle bisector. The angle bisector of the vertex angle of a triangle divides its opposite side BC, that is a BD by DC is equal to BA by AC. This is the most important. Okay. So where AD is a angle bisector. This is called vertical angle bisector theorem. So vertical angle bisector theorem means here the angle bisector of the vertex angle divides its opposite side in the ratio, means BD by DC is equal to the remaining 2 sides BA by AC. So we can extend this some other external angle bisector theorem also. This is the most important. Now coming to the most important theorem is, we call it as midpoint theorem. Midpoint theorem. This is the most important. It's an application of basic proportionality theorem. You know it. And a midpoint theorem means in a triangle ABC, the line drawn from the midpoint of one side parallel to the other side divides the third side in the same ratio. Clear? This is called midpoint theorem. Okay. We can say the converse of midpoint theorem is the line segment which joins the midpoints of any 2 sides of the triangle divides, or simply you can say the line segment joining any 2 sides is parallel to the third side and half of its length. Like we can say converse of the theorem. Are you understand? 2 statements. The first one is a midpoint theorem. Midpoint theorem is the line drawn from the midpoint of one side parallel to the second side bisects the third side, means divides in equal ratio. This is a midpoint theorem. We can say converse of midpoint theorem as the line segment which joins the midpoints of any 2 sides is parallel to the third side and half of its length, means AD is equal to DB, AE equal to EC, then DE is parallel to BC and DE is equal to of BC. This is the converse of midpoint theorem. Clear? So these are the very important theorems. So by using this we can do and so many problems in the geometry area. Okay, now we will shift to the problems. We will discuss 1 or 2, then we will come to the concept once again. Okay. Now see, write the question here in a triangle ABC. A is twice angle B. Angle A is twice to angle B. Then find the value of A square. Maybe ask like, or simply show that A square is equal to B of B plus C. In a triangle ABC, angle A is twice to angle B and A square equal to B of B plus C. You are going to show that. The question may be asked like, or find the value of A square in terms of B and C. They may ask the question like, okay, then how to do it? Any idea from your side? See, the step, each step is a very good logic. So this logic is very, very important. Okay. So what is the given information? If you want to do the problems, especially in the geometry, you have to follow what is given and what is required. So first you have to write what is given and what is required, then how to do it. This is the most important. So we call it as, this is a direct method. Okay. Sometimes we are going to use the indirect method also to prove the statements. This is purely a direct method I am using from if you start from given and we end up our proof with a conclusion, that we will call it as a direct method. Another method we call it as indirect method. Indirect method means here we will start with a contradiction to the required to prove or conclusion, and we will complete the procedure. At last we will find that, we will say that our assumption is wrong and given statement is correct. That is called indirect proof. So generally 80% of the problems will be done by direct method and remaining 20% will be indirect method. Where direct method is difficult to apply, then we can apply the indirect method to get the answer. Clear? So in the triangle ABC, angle A is twice to angle B, means it is a given information. So we can say angle A equal to 2 times of angle B, correct? So angle A is twice to angle, it is a communication. We are representing the same statement in a mathematical sense. Okay. Now we are going to prove that angle A equal to 2 times of angle B. So any idea from your side? I am writing this one is A minus B is equal to B. Are you understand this? So here 2B you can write it as B plus B, correct? So I send one of B to this side, then A minus B equal to B. So why I am writing the steps so directly means here it is a very important when you are doing this question solution in the examination, these are very important. Don't depends on the already ancient method, means we will write more number of steps, that is not correct. The procedure will be given very important. Presently in CCE system we are evaluating the children only for how the children is representing the data. So we are not giving lengthy methods or writing more number of steps. Even it is simple, we will give the full marks to it. I will give a small example to you. In the examination in 2015, we gave one question to the children in the examination, that is in the progression chapter, yes, sum of 7 terms equal to 49. Sum of 17 terms, first 17 terms is 289. Then find sum of the first 30 terms. This is the question. Sum of 7 terms of the arithmetic progression is 49 and sum of 17 terms of the arithmetic progression is 289 and sum of 30 terms find that. Actual procedure is you have to follow the progression of sum of the n terms of a progression, then you have to write n by 2 of a plus n minus 1 into d, 2a plus n minus the formula. You will get one equation in terms of a and d, again you will get another equation in terms of a and d by using S17, solve those, find the values of a and d, and finally you have to find a S30. That is a lengthy method. Actually the same method was given in the textbook also, but S7 equal to 49, you can write it as a 7 square. S17 equal to 289, we can write it as it's 17 square. Means when S7 7 square, S17 17 square, then Sn equal to how much? You can expect this as n square. So S30 will be 30 square, which is 900. Answer is over. By one step answer is over. The same question was given as 4 marks. In the principles of evaluation, we announced that if the children did this question in the same manner, award 4. There is a myth in the minds of the teachers is so we will write 4 steps or 5 steps, 6 steps. It's not correct. So if the solution is elegant and correct, we can give the full marks to that. It's a simply already day before yesterday I discussed the concept of various methods. One of the method is induction method. The children applied induction method. For one case it is true, for the second case it is true, for some cases it is true, then for all cases it is true. So you can say S30 equal to 900. Is it clear? So like so we have to apply. So how lengthy we are doing, that is not the correct way. How simple, how best we are doing the solution is the most important. Okay, now coming to this, A equal to 2 times of angle B, then I write it as 2B, 2 times of B as B plus B, which is simply as A minus B of A plus of A minus B into B. Now applying the sign for this, I applied the sign for both sides. So sine of A minus B is equal to sine B, correct? I applied sign for both sides. What is the use? It is an application of trigonometry in geometry. So sine of A minus B equal to sine. Now I am going to do multiply both sides with the sine of A plus B. In sine of A minus B into sine of A plus B is equal to sine of A plus B into sine B. Okay, now I am applying that. Sine of A minus B into sine of A plus B, you can say it as sine square A minus sine square B, correct? So you know that sine of A minus B and sine of A plus B equal to sine of A plus B into sine B. So maybe you have a doubt, sir, this is a little bit of out of standard. Don't feel that, because you are writing the examination exactly in your standard, but little bit of higher concepts also they may ask. So no, so we will strictly follow the same concept. You have to follow these things also, then it's a good for you. This is most important. Okay, now I am taking a concept is, you know that A plus B plus C is equal to 180 degrees. Sum of 3 angles is equal to 180. When A plus B plus C equal to 180, you can write it as A plus B is equal to 180 minus C. When you apply sine on both sides, sine of A plus B is equal to sine of 180 minus C. So it is sine C. So what is sine of A plus B? We can say sine C. Now I am using the same here, sine C and sine B. Clear? Okay. Now I am going to use the concept of sine law. Okay. Then we can find the area means here 2r sine A. I am going to use, so for that reason, sine square A minus sine square B. So I am multiplying with 4r square on both sides for each term. So I am going to multiply 4r square means here it is 4r square sine square A, and this is 4r square sine square B, and this 4r square I will write it as 2r sine C into 2r sine B. So is it clear? So 4r square sine square A minus 4r square sine square B is equal to 2r sine C of 2r sine B. Okay. Now I will write the rest of the steps here. Just observe it. You can write 4r square sine square A as 2r sine A whole square. 4r square sine square B, you can write it as 2r sine B whole square. Then you will come to as a 2r sine C into 2r sine B. 2r sine A. Okay, now I am going to use it. You know that sine law is A equal to 2r sine A and B is equal to 2r sine B and C equal to 2r sine C. Now I am going to use this concept. Okay. So 2r sine A is A square, 2r sine B is B square, and 2r sine C is, of course, it is C, and 2r sine C is B. Now I am writing as A square equal to, I am sending minus B square to that side, it becomes plus B square, B square. Or you can take that as B common, B of B plus. So A square equal to B of B plus C. Is it clear? So we can find A square equal to B of B plus C. This is the most important. It's an application, but don't feel that every question comes and this same area. So 1-2 questions maybe means it's I gave this question as an example for application of trigonometry concepts in the geometrical areas. This is very important. Clear? Okay. Shall we move to another one? It's a very good thing. It's connected with the number system and the geometry. This is a very important. So we'll see that how the number theory plays in the geometry area to give an excellent concept for it. So all of you have write the question, that is in a triangle ABC, the in circle touches all the three sides that is BC, CA, AB at D, E and F respectively. Okay. If the radius of in circle is 4 units. If the radius of the in circle is 4 units and if BD, CE and AFs are consecutive integers, then find the lengths of the sides of the triangle. Okay, this is the question. In a triangle ABC, the in circle touches all the three sides BC, CA, AB at D, E and F respectively. If the radius of in circle is 4 units and if BD, CE, AF are consecutive integers, then find the lengths of the sides of the triangle. This is a most important question. Very good question. So just observe it, the way of procedure. So how it covers the maximum concepts. Okay. Now I am drawing the with respect to data. ABC is a triangle, correct? In circle touches all the three sides. At D, E and F. I know that I is the in center. It is 4 units. In radius is given as 4 units. Correct? You are going to find, and one more information is given, BD, CE and AF are consecutive integers. Then you are going to find the lengths of all the three sides. Clear? Okay. Then how to do this? Any idea from your side? Here I am taking only 2 areas. One is in radius, relation with in radius with the area, and the second one is Heron's formula. These two will get the answer. Very simple. Okay. What is in radius formula? You know that R is equal to delta by S. So R equal to delta by S. So I am using one, and the second one is delta is equal to root over S of S minus E of S minus B of S minus C. I am going to use these 2 formulas to get the total answer. Okay. Then what is the given information? This is very, very important. So we will say these BD, CE, AF are consecutive integers. So now for our convenience, I will say BD is n minus 1, CE is n, and AF is n plus 1. N minus 1, n plus 1. You know that these are 3 consecutive integers. Am I correct? Okay. Now I am taking these 3. So when it is n minus 1, now coming to the application of circles. You know that in a circle, when you draw two tangents from the external point, the lengths of the tangents are equal. This is a tangent, BF is a tangent to the circle, BD is also a tangent to the circle, and both are drawn from the same external point B. So, BD is equal to BF. So, when it is n minus 1, this is also n minus 1. Am I correct? Okay. Now, coming to the next. CD and CE. CD and CE are also two tangents which are drawn from the external point C. When CE is n, so CD also n. So, it is n. Okay. Now, coming to the next. You know that AE and AF both are same, because those two are tangents which is drawn from the external point A. So, when it is n plus 1, this is also n plus 1. Okay. Now, you can say the lengths of each side AB, n plus 1, n minus 1, n plus 1, n minus 1, which is 2n, and the length of BC, n minus 1 plus n, which is 2n minus 1, and CA or AC, n plus 1 and n. So, n plus 1 plus n, it is 2n plus 1. So, the lengths of the sides are, you know that 2n, 2n minus 1 and 2n plus 1. These are the lengths of the sides, correct? Now, I am going to use that by using this one. So, first I want to use the delta. So, delta means here you know that S is the semi-perimeter. What is S here? A plus B plus C by 2 means sum of these 3 by 2, which is equal to 2n plus 2n minus 1 plus 2n plus 1 by 2. And this minus 1 plus 1 get cancelled. 2n plus 2n plus 2n, which is 6n. 6n by 2 means here 3n. Okay. So, S is equal to how much? 3n. Is it clear? So, I will erase some of you, then I will write the rest of the steps here. Now, I am going to use the area formula. Of course, you know that delta is equal to S is how much? 3n. First one, say this one we call it as BC, no? We will say it is A, and this one as B, and this one as C, because opposite vertices. So, we can write a first one root over S. S is total 3n. Okay. Next, 3n minus S minus A, 2n minus of 1. Okay. Next, 3n S minus B, 2n plus 1, 3n minus 2n. Correct? This is delta. Now, I am writing this one as 3n. 3n minus of 2n minus 1. What is its value? 3n minus 2n minus 1. Minus of minus plus n plus 1. 3n minus of 2n plus 1 means here 3n minus 2n minus 1 means n minus 1. And 3n minus n, which is n. Correct? You can say it as 3 n into n, n square. N plus 1 of n minus 1 is n square minus 1. This is delta. Correct? Okay. Now, we will see, you know the value of delta. How much the value it is? 3n of n square minus 1. So, here delta is equal to R by S. Correct? We can say delta is equal to R by S. Or you can say R equal to delta by S. Same answer you can say delta is equal to, you find that square root of 3n square of n square minus 1 is equal to 4 by S. S is how much? 3n. Correct? Now, we can say the same value square root of, we can simply will the square the on the both sides. When you square on the both sides, R is equal to simply this one. are equal to delta by s. So, square root of 3n square of n square minus 1 by how much? Its value is how much? We can say by 3n. By 3n you can say it, which is equal to 4. So, 4 square 16 is equal to 3n square of n square minus 1 by 9n square. Correct? So, we can cancel 3n square. Here 9n square means here you will get is how much? It is 3n. n square minus 1. So, n square minus 1 is equal to how much? You will simply get is 40. This is also n also cancel, only 3 will become, correct? 3. So, it is 3 square of course 16, 16 3s are 48. So, n square equal to how much? 48 plus 1, or you can write it as 49 square, 49. Otherwise, you can write it as n square equal to 7 square. So, we can write n is equal to 7, correct? Okay. Shall I erase it now? Now verify it. What are the sides you got it? One is 2n, 2n minus 1, 2n plus 1. What is the value? N equal to 7. So, one side is 2 of 7, which is 14. Other one is 2 of 7 minus 1, 14 minus 1, 13. One more is 2 of 7 plus 1, 14 plus 1, 15. So, there may be 30, 14 and 15. Correct? Like you can find the sides of the triangle. So, like the question comes the connecting one area to other area, especially inside the maybe intra connections or inner connections. So, this is the most important. So, one more concept, very important concept, they may ask in the examination also, because in the textbook we gave an excellent concept, call it as a 9-point circle. This is a very important. What is a 9-point circle? Just remember this: A, B, C is a triangle. We have to draw 3 altitudes from the 3 vertices. Name it as, for example, for our convenience, I am put up the altitudes as 1, 2 and 3. Consider the midpoint of all the 3 sides. Name it as 4, 5 and 6. You know that the point of concurrence of the altitudes is called orthocenter. Name it as O. Now, take the midpoints of OA, OB, OC. Okay. Name those as 7, 8 and 9. Join 7 and 4. Take the midpoint of 7 and 4, which will be considered as a 9-point circle. Take either the distance between n and 4 or n and 7 as a radius, draw a circle. That circle will passes through all these 9 points. This is called 9-point circle center or 9-point. What is the importance of this 9-point mean circle means here, when you consider as O as the orthocenter, S as the circumcenter, N as the 9-point circle center, then ON is equal to NS. ON equal to NS. This means N is the midpoint of OS. The line segment which joining the orthocenter and the circumcenter is the midpoint of that line segment is a 9-point circle center. It is a very important. And one more important concept of this means here, the circumcenter will differ from one kind of triangle to other kind of triangle. Clear? The incenter always lies inside, but the orthocenter differs from one kind of triangle to other kind of triangle. The circumcenter also differs from one kind of triangle to other kind of triangle. This is the most important. For a circumcenter, when you consider, when it is an acute angle triangle, the circumcenter lies inside. When it is a right angle triangle, the circumcenter is the midpoint of the hypotenuse. When it is an obtuse angle triangle, the circumcenter lies outside. This is the most important. Whereas when you consider orthocenters, when it is an acute angle triangle, it lies inside. When it is a right angle triangle, it is the vertex of the right angle. When it is an obtuse angle triangle, it lies outside. And the one more, you know that this is called a centroid. It is a point of concurrence of the medians. Okay, the centroid lies always inside, whether it's a right angle triangle, equal, of course, acute angle triangle, obtuse angle triangle. This point of concurrence is also very, very important. Okay, now, so you learn some of the concepts about the triangle and its application. And the next class we will discuss about the circles and its properties and all other interrelations. Clear? So thank you for listening. Have a nice day.